So we need to find out the value of sine A minus B and cosine of A plus B. And it's given here the value of cosine A and cosine B. Also, there's a condition here that the two angle A and B lies between 3 pi over 2 radians and 2 pi radians. Let's try to understand the problem. So first, let's say we need to find out the value of sine A minus B. Now we know that this can be expanded as sine of A multiplied to cosine of B minus cosine of A times sine of B. Now clearly we are being provided with the value of cosine of B as well as cosine of A, but we have to find out the value of sine A as well as sine B in order to find out the value of sine A minus B. Okay, so let's do that. Now to begin with, we'll start with our given trigonometric ratio, which is cosine of A that's equals to 4 over 5. Now to find out the value of sine A, we're going to use the trigonometric identity. We know that sine squared theta plus cosine squared theta, so that's equals to 1. That's a standard identity. To find out the value of sine theta, all we have to do is rewrite in the form as plus or minus square root of 1 minus cosine squared theta. Meaning, if we know the value of cosine theta, then we can immediately find out the value of sine theta. Now in the case we have cosine of A, so we can find out sine of A by using the formula plus or minus square root of 1 minus cosine squared A. So here our angle theta is represented by A. So let's plug in the value. We have plus or minus square root of 1 minus. So we have cosine of A given by 4 over 5. So when we square it, that gives us 16 over 25. Solving this gives us the value plus or minus 3 over 5. Now here we are getting two values, a positive 3 over 5 and the other ratio is negative 3 over 5. But we'll have to consider only a single value. To do that, we'll look at the quadrant in which angle A lies. So it's given here. So let's first try to understand this with the help of the Cartesian plane. So we have our first quadrant, second quadrant, third quadrant, and our fourth quadrant. The first quadrant lies between the angle 0 and pi over 2. The second quadrant lies between pi over 2 and pi radians. The third quadrant, the angle lies between pi and 3 pi over 2 radians. And then we have the fourth quadrant where our angle lies between 3 pi over 2 and 2 pi radians. So it's given here, both angle A as well as angle B lies between 3 pi over 2 and 2 pi. That means it lies in the fourth quadrant. Now, if we use the mnemonic A, S, T, C, so C tells us that only the cosine and the secant functions are positive in the fourth quadrant and all the remaining trigonometric ratios are going to be negative. So that means we'll have to consider the negative value of sine A. So sine of angle A will be equals to negative 3 over 5. Now that we have the value of sine A, our next task will be to obtain the value of sine of B. For that, we will use cosine of B. So cosine of B, that's given as 12 over 13. So sine of B will be equals to plus or minus square root of 1 minus cosine squared B. We'll plug the value of cosine of B, and this is going to give us cosine of B equals to plus or minus 5 over 13. Now, should we use the positive value or the negative value? So that will be determined by the quadrant in which B lies. So B lies in the fourth quadrant. It's given here in the problem. So in the fourth quadrant, only cosine and secant are positive. Everything else is negative. And we are working with a sine function. So we should get negative 5 over 13. Now that we have the value of sine A, cosine B as well as sine B, now we can find out the value of sine A minus B. So let's do that. So therefore, number 1, the problem 1, which is to find out the value of sine A minus B, we have sine of A. So sine of A, we found out that this value is negative 3 over 5. This is multiplied to cosine of B, which is positive 12 over 13. Minus, we have cosine of A. So cosine of A, that's positive 4 over 5. Multiplied to sine B. So sine B is negative 5 over 13. So let's solve this. So negative 3 times 12, so that's negative 36 over 5 times 13 is 65. Then we have 4 times 5, so that's 20 over 65. And we have negative multiplied to negative 5, so we'll get positive. Solving this gives us the value negative 16 over 65. So this is the value of sine A minus B. Our next task will be to find out the value of cosine of A plus B. For that, let's use the value. Then we know that cosine of A plus B, this will be given by the formula cosine of A multiplied to cosine of B minus sine of A multiplied to sine of B. So cosine of A, we have already defined, we have already been provided with that value, that's 4/5. So we have 4/5 multiplied to cosine B, that's 12/13. Minus sine A, so we have obtained the value of sine A as negative 3/5, and sine B came out to be negative 5/13. So solving this is a very simple arithmetic. So solving this value, we're going to get positive 33/65. So we have successfully found out the value of sine A minus B as well as cosine of A plus B.